Hey there, your tens. So today I'm going to start a lesson about negative powers, similar to how we did the other day's lesson yesterday, I think, by talking about the zero index and why does anything to the power of 0 equal 1. So I'm going to use the same idea. So if we follow this pattern, if you take 8 and you divide it by the base, you divide it by 2, you're going to get to 4. Take 4 and divide it by 2, you're going to get 2. If you take 2 and divide it by 2, you're going to get to 1. So anything to the power of 0 is equals 1 where we were at yesterday. So now, if you take 1 and you divide 1 by 2, you take 1 and split it into 2 equal chunks, you get a half. If you take a half and divide half by 2, you're going to get a quarter. And this kind of pattern keeps going, so the next one you get is you divide a quarter in half, you're going to get an eighth. That's kind of how one way to think about the why do negative indexes make fractions. So you notice as soon as you dip below 1, as soon as you get to the negative indices, you're going to end up with fractions. I'm going to look at a couple different ways to prove it. This is just one, looking at a numerical pattern. So let's look at another one, base 10. So we'll divide by 100 here, or not divide by 100, divide by 10 here. Wow, sorry, a little tired. And I get 100, so that's divided by 10. Again, 100 divided by 10. 10 to the power of 1 is just 10. If you divide by 10 again, if you divide by 10, 10 divided by 10 is just 1. 10 to the power of 1 is 1. This is where we can start using the same pattern we used before. What's 1 divided by 10? What's 1 divided by 10? And you notice it's the next one. So next step, 10 to the power negative 2 is 1 to the 100. And I really what I'm doing is I'm kind of cheating. I'm looking up above. So the first one is 10. It's 1 over 10. Next one, 10 to the power of negative 2 is really just 10 to the power of 2, but it's 1 over 100. Next one will be 1 over 1,000. And that's kind of how I got those. You notice again, as soon as you dip in the fractions, you get fractions. It's not negative numbers, it's going to be fractions. So another proof of this that I like, oh, did I lose my page? I may have lost my page. I'll just take a second to reload it here. So consider this. So if I gave you 2 to the power of 0 divided by 2 to the power of 3. So another way to write this, if you want to think about this, is you can write it as 2 to the power of 0 divided by 2 to the power of 3, right? The first part of the problem on the top, division turns out as a fraction, and then the second number becomes the one on the bottom. So we know from yesterday, or sorry, I can just draw that as an equals, you know, from the other day that anything to the power of 0 is 1 over, and then you can do 2 to the power of 3. Just let me use my calculator, 2 to the power of 3, and I get 8. So I literally evaluated, I figured out the top, and that equaled 1. And then I did 2 to the power of 3, and I got 8. So that's another way that we can prove that anything with a negative integer, because in reality, you know from your rules the other day that 2 to the power of 0 divided by, you know the indices law, that when we divide, we subtract, and then that would be 2 to the negative 3 equals 1 over 8. So I hope that kind of makes sense. So we can now look at this as an overall pattern, and we can apply this. But I had all my pages ready, and they've all crashed on me. I think this is the one I want to do here. If not, I'll close it and try again. Nope, not that one. Let's try, looks like I lost that one here. I'll try to do a new from a new image. Let's try that one there. Let's see if this is it. Perfect, okay. So the way we can look at this rule is any number to the power of 1. So if I gave you any number to the power of negative, if you have a negative, it's going to become a fraction. So the first thing I do is I write equals 1 over. That takes care of the negative part of this. So that takes care of the negative. I then rewrite it as 2 to the power of 1. And really, 2 to the power of 1 is just 2. So that is 1/2. Try the next one out. So again, we start out by writing 1 over. By turning it into a fraction with 1 over, write my base, and because we've taken care of the negative by writing it as a fraction of 1 over, we can then now write the power of 3. So then we can go like this, and we can say, all right, that's 1 over, and then I can go 5 to the power of 3 equals, I'm doing this on my calculator. I know you guys know that I probably couldn't evaluate that in my head that fast. And then this one, I would go equals 1 over g to the power of 5. And really that's as far as I can go. I can't evaluate that any further because we do not know what g equals, so we cannot evaluate that any further. That's as far as we can go. Let's look at one last example. This one stayed loaded for me. Okay, so I'm going to break this apart because I think some of this was getting lost the other day on you guys when we were talking about 0. Let's see. So when I look at that equation right there, it's not the neatest bracket I've ever drawn. It's a bit better. This really means 3 times n to the negative 2. So then I'm going to keep going. I'll say that equals to 3 times. Now let's take care of the negative first. We'll turn in a fraction, 1 over n to the negative 2. And then finally, we can then multiply this in. What's 3 times 1? 3 over n to the power of 2. So if that's not neat, I'm trying to draw those as n's. Okay, let's try this one. This one looks the same, but there's a big difference. There's the brackets. That means this negative 2 applies to everything inside. Not just the n, but everything inside is what it applies to. So I'm just going to take a second and clean that up. So it makes it a little bit different. So the first thing I do is do equals. Let's deal with the negative first. So I turn that into a fraction, 1 over, and then I put everything that's inside the brackets, because the brackets mean this applies to everything inside the bracket. So I go n squared. So that's kind of a good place right there. The other thing to realize, it also means that this 2 applies to everything inside. So really, it's now going to be 1 over 3 squared n squared. Then I could say that's 1 over 9n squared. Is it evaluated? Perfect. So the next one, let's go with this one. So we've got 2 prime numerals. You notice we've got the one prime numeral with a negative 2 and the second one with just a 3. So it's going to be pretty easy to do. The first thing I'll do is I'll deal with my negative. So I make this. Also, sorry, before I even go to that, think of it as p negative 2 times q to the power of 3. So just remember that when you don't see an operation between the two, it means multiply. So now I can deal with this. I make it 1 over, that deals with the negative. And I go p squared times q to the power of 3. So now I can multiply these. I can go 1 times q to make it q to the power of 3 over p to the power of 2. Grand finale. Notice, no brackets. That means this negative 6 only applies to the b. It doesn't count for the a. So this also means a times b to the negative 6. That's what it means. So now I go a times, let's do the negative first, 1 over b to the 6. Now I can multiply a times 1. A times 1 is a over b to the power of 6.